1.3, we are going to display quantitative data with numbers. Do you guys remember the graphs that we use for quantitative data? What graphs can we use for quantitative data?
Histogram.
Histogram?
Pie chart.
That's categorical.
The
Stem and leaf plot?
and then the dot.
The dot plot.
Yeah, that's what I said.
Bar graphs and pie charts are for what kind of data? Categorical data. Very good, ladies and gentlemen. Very good. Here we go. What are the two ways that we have described the measures of center? Mean and median. Mean and median are easy, right? Of course they are. Well, ladies and gentlemen, we're going to talk about the mean. We're going to zero in on the mean for a few minutes, okay? How do you guys find mean?
Add them up and divide.
Add all the numbers and divide by the number of numbers. Easy, right?
Always.
I am now going to show you the statistical notation and formula for the mean. Are you ready? X bar. X bar. Everybody say X bar.
X bar.
That is how you say that right there. That is X bar. What does X bar stand for?
X bar.
The mean. It's the mean. It's the mean of a distribution. X bar equals the summation of X sub I divided by N.
Baconator, I don't know what that means.
Ma'am, I did not sign up for pre-cal or calculus on purpose. Okay, this is not pre-cal or calculus. This is notation. Ladies and gentlemen, how do you find the mean of a distribution? Tell me.
Add them up.
You add all the numbers and divide by the number of numbers. That's all that is. That's all that is. All right, so check this out. What is this fancy little E looking symbol? This is a sigma. You're welcome. If you want to be in a fraternity or sorority, this is sigma. Okay? This is sigma. All it means is to sum the values. Sum the values. That's all it means. It's just a summation symbol. Now, X sub I. That's what I'm saying. X sub I. X sub I. Why sub? It's a subscript. The I is a subscript. X sub I. All this means is all the values in the distribution. Each X value, each variable in the distribution. That's all that stands for. Okay? X sub I is just all values in the distribution. No big deal. Easy peasy. And then what do we divide by when we're doing mean? The number of numbers. Now, in stats, when I'm talking about how many values are in a distribution, we call that the sample size. And it is notated with a lowercase n. This is just n, which is the sample size. Sample size. That's it. Okay? So, the middle school mean that you've been doing where you added all the numbers and divided by the number of numbers, you're still doing that. It's just now you know the fancy notation for it. Okay? Make sense? What's this guy called?
Mean.
Let's write it down.
X bar.
This is X bar, X bar, X bar. Literally X bar. Why do you guys think that's called X bar? It's X with a bar on top. It's pretty great, right? All right, cool. Do you guys have any questions, comments, concerns about this? All right. You guys already know how to find the mean. So here is a very small data set of 15 randomly selected SAT scores from students that are currently enrolled in AP Stats. Pulled this data last night and updated it. There are 15 values here. I need you guys to calculate the mean of these 15 SAT scores. Go. You got. Yeah, so here's the deal about median and outlier. I'm going to skip something real quick. I'm skipping that. I'm at the bottom of your page for a second. Is the median sensitive to extreme values in the distribution? Now, for our specific example, the median did change a little bit, Okay? It went from one number down to the next. But that's because we had a small set of data. Like 35 values is still a pretty small set of data when we normally work with populations in the thousands. Think about if we had 1,000 people's data. Would taking one value off of an end change the median very much? No. Probably not. The median is not usually sensitive to extreme values in large distributions. A little bit in smaller distributions, but not very much. So, is the median sensitive to extreme values in a distribution? Not for large populations. Therefore, median is said to be resistant. The median is said to be resistant because in large populations, if you take out one number on the ends, it's not going to change your median very much. Any questions about that? All right, now I'm going to go backwards to that last question that we skipped. How are the mean and median related? So, I want to show you guys this. Alrighty. All right, you guys, what shape would you say this distribution is? Roughly symmetric, unimodal, okay? All right, cool. The mean is in green, the median is in red, and there's these little arrows right here that are also green and red. What do you notice about the mean and the median? They're like pretty close, okay? So in a symmetric distribution, the mean and the median are pretty close. Do you agree? Yeah. Perfect. All right, now what's going to happen if I start putting data on the right over there? I would have a skewed distribution. Which way is it going to be skewed? I'm going to go that way. Okay. This is skewed right. This is skewed right. Just flip it this way. Skewed right. What happened to the mean? It increased. It was like, oh my gosh, what's going on down there? I'm going to go check it out, right? It's not resistant. It can't help it. It has to go see what's going on. What did the median do? Stayed the same. The median resisted going down there to see what was going on. The median stayed right where it was, but the mean was not resistant and had to go that way. So in a right skewed distribution, the mean will always be greater than the median. Okay? What happens in a left skewed distribution? Any guesses? Whee! Lots of little clickies. So what's occurring here? What kind of distribution do we have? Roughly symmetric. All right, cool. All right, roughly symmetric. And my mean and median are pretty close to the same-ish. There we go. Okay, mean and median, pretty close here. Okay? And when I start trailing off this way, here comes the mean. Woo, what's going on down there? There's skewed data. I can't resist. Not resistant. So the mean averages and goes toward the skewed data, but the median resists and stays right where it is. Okay? So in a left skewed distribution, which this one is, in a left skewed distribution, the mean is less than the median. Okay? So we're going to summarize all that and draw a little picture, or you can just write it out, your call. So here is what we have. We had an approximately symmetric distribution. And in that situation, my mean was pretty close, about equal to my median. And both of them were right here in the middle, pretty close to where the peak was. Okay? Maybe a slight off, but pretty close to the same number. So if I were to show you, like, I don't know, 4.65 for the mean and like 4.68 for the median. I mean, would you guys agree those are fairly close to the same numbers? Yeah, so those would be pretty symmetric. All right, left skewed. Here's a left skewed distribution. Now, where's the median in a left skew distribution? It's going to be close to the peak. I'm not saying it's the exact peak, but it's going to be pretty close to the peak. So the median is going to be fairly close to your peak. But what about the mean? Which way does the mean go from the median? It's going to go to the left, because it's trying to average out all of these lower numbers. So that brings the average down. So the mean is going to be down this way. Remember, that's x bar. X bar is the mean. So numerically speaking, the mean is less than the median. So I can literally give you two numbers in a distribution and you can tell me its shape. I can tell you that the mean equals 147 and the median equals 182. And just from that information alone, nothing else, you could tell me it's left skew, because the mean is much lower than the median. So just from that, you can tell me the shape. Right skewed is the exact opposite. So we have our right skew distribution. Our median is slightly to the right of the peak, but our mean is somewhere further to the right because it's trying to average out those outlying values. How far? I don't know. It depends on what the outliers or the skewed data is. The more the skew, the further out it is, the further down the mean's going to go. But in this situation, the mean is numerically larger than the median. So greater than. Yep. The mean is greater than the median. If I gave you two numbers, let's say the mean is 27 and the median is 5. Just from that information, you could tell me the skew, that it's right skewed. What questions do y'all have about mean and median? Again, something very basic that you know a lot about, mean and median, but this just takes it to a whole nother level, okay? Cool? Cool, we'll stop there for today.